2.6, Finding equations of lines and applications. So we're going to take what we learned about lines and kind of extend our learning a bit further. Let's begin with this first example. Find the equation of a line that has a slope of negative 0.7 and a y-intercept of 13. Well, we haven't talked about how to go from a slope and a y-intercept to an equation, but we know an equation that labels and highlights the y-intercept and the slope. We have y equals mx plus b. And if from that equation we can easily pick out our slope and our y-intercept, then why can't we go from our slope and y-intercept to an equation? Well, we can. This is our slope, and that 13 will be our y-intercept. So that our answer would be y is equal to negative 0.7x plus 13. And that is our answer. Now, if we're not given specifically the y-intercept and the slope, there are equations to help us get to the equation of a line, such as the point-slope equation. The point-slope equation of a line with slope m passing through points x1 and y1 is y minus y1 times m is equal to m times x minus x1. So we have to fill out those highlighted values, y1, m, and x1. And when we see the point x1, y1, it has a little subscript of 1 to show us that that is our point 1, our point that we're working with. Example, find the equation of a line with slope of 5 containing the point 1/2 and negative 1. Well, we just learned of an equation that will help us do that right above. We have y minus y1 is equal to m times x minus x1. All right, well, we have our slope, we have our m of 5, and we have our point. We have our x1, y1. So that we have y minus my y1 is negative 1, is equal to m, my m is 5, times x minus, what is my x1? My x1 is 1/2. And there we have it. We have set up our equation. Now it's just a matter of simplifying. So to begin, we see that we can change this to addition. It looks like a smiley face, doesn't it? And we can distribute that 5. So that we have 5x minus, I'll do that side work on the side. How do we multiply fractions? We have 5 times 1/2. We can write the 5 over 1 and we multiply across. So we have 5 over 2. So we have negative 5 over 2. And on the left-hand side, I have y plus 1. Okay, if I continue, now I need to get the y by itself, so I subtract 1, subtract 1. So we're left with y is equal to 5x. And now we're left to do this work here, do the subtraction. I know subtracting fractions is something that can be tricky, so let's go ahead and do this together. So we have negative 5 over 2 minus 1. Well, we need a common denominator. So we need to write as negative 5 over 2 minus 2 over 2. So we have negative 7 over 2. And that is our answer. Another example. Find the equation of a line containing the points 2, 3, and negative 6, comma 1. Well, it's just as our problem above. The only difference is I'm not given the slope. I have to figure out the slope by myself. Well, luckily, we have a formula that will help us find the slope. Our slope is found from our equation y2 minus y1 over x2 minus x1. So I just have to go ahead and label my points. x1, y1, x2, y2. All right, let's find our slope. My slope is y2. Y2 is 1 minus y1. Y1 is 3 divided by x2, negative 6, minus x1, we get 2. So we have negative 2 divided by negative 8, which gives us positive 2 over 8. And that can be simplified by as 1/4. So my slope is 1/4. Now I'm left to use my point slope formula to find our equation of a line. Recall your point slope formula. Our new formula we learned is y minus y1 is equal to m times x minus x1. And that's the formula right above that we just learned. Okay, so we need to pick a point to be x1 and y1. It doesn't matter which point it is as long as we're consistent, meaning we pick the x and the y from that same point. How about we pick that first one, x1, y1. Okay, let's go ahead and use substitution so that I have y minus y1. Y1 is 3 is equal to m. We found m was 1/4 times x minus x1, and x1 was 2. All right, let's go ahead and simplify. So let's distribute that 1/4. 1/4 times x is 1/4 x. 1/4 times negative 2, well, that gives us 1/4 times 2. That gives us 2 over 4, and that simplifies to be 1/2. So I have negative 1/2. On the left-hand side, I have y minus 3. Let's go ahead and add 3 to both sides so that I'm left with y is equal to 1/4 x plus 2.5. Or let me do that work for that too. Negative 1/2 plus 3 over 1. I need a common denominator, so I need to multiply top and bottom by 2. So I have negative 1/2 plus 6 over 2. That gives us negative 5 over 2. Minus 5 over 2. And that is our answer. Finding an equation of a line parallel or perpendicular to a given line. So before we begin, let's recall what it means to be a parallel line. Parallel lines are parallel because their slope is the same. Perpendicular, we know we have a perpendicular line because their slopes multiply to give you 1, meaning they're, well, negative 1. They're opposite reciprocals. So you need opposite sign and reciprocals, meaning you flip your fraction. Okay, so our example reads, find an equation of the line containing the point negative 1, 3 that is parallel to the line 2x plus y. All right, we want parallel. So what we want to do is we want to steal the slope from this equation. Let's go ahead and give this a try. So to begin, let's get y by itself. So minus 2x minus 2x. So we're left with y is equal to negative 2x plus 10. All right, we're in not point slope. We're in slope-intercept form so that I can easily steal my slope. And what is our slope? Our slope is equal to negative 2. Okay, now that we have our slope, we can manipulate it to answer our question. So our question is asking to find the equation of a line containing the point negative 1, 3 that is parallel. So I just need to steal that slope and use that point. All right, if I wish to use a point and a slope, then I use my point slope formula. So let's recall it. That formula is y minus y1 is equal to m times x minus x1. Let's label our points x1, y1, and we have our slope here that we're going to seal. Okay, so now we have y minus y1, we said y1 is 3, is equal to m, my m is negative 2, times x minus x1, my x1 is negative 1. Okay, let's clean this up. So here a negative and a negative gives a positive, and then we need to distribute that negative 2. So that we have negative 2x minus 2. On the left-hand side, I have y minus 3. I add 3 to both sides, plus 3. We're left with y is equal to negative 2x plus 1. And there we have it. We create a line with that point that is parallel to that line that is given. Another example. Find the equation of a line containing the point 2, 3 that is perpendicular to the line for y minus x equals 20. All right, so given that line, that equation of a line, I want to manipulate the slope. So I was given, or we were given, y for y minus x is equal to 20. Let's go ahead and solve for y. So we have plus x on both sides. And I have 4y is equal to x plus 20. We want y by itself, so let's go ahead and divide by 4. So that we're left with y is equal to, we have 1 over 4x plus, what is 20 divided by 4? That gives us 5. Remember that 4 divides both numerators. And every time I do that, I say, yes, I did draw a heart. Okay, so we're given our slope. Now I need to manipulate it. Now for a perpendicular slope, I need a slope that is opposite, different sign, and reciprocal. You flip your fraction. So our new perpendicular slope, would be, well, here I have a plus, so this one would be a negative. There I have 1/4, so here I'll have 4 over 1, which is just negative 4. So that is our new slope. Okay, we're going to use our slope and our given point to create an equation. Recall your equation is y minus y1 is equal to m times x minus x1. Let's fill in our pieces of information. So we have x1, y1, and we have our slope. So that we have y minus y1 is negative 3, is equal to m, which is negative 4, times x minus x1 is 2. Okay, so these two negatives make a positive, and then I'm left to distribute this negative 4. So that we have negative 4x, and a negative times a negative is positive, so plus 2 times 4, 8. And we have y plus 3. All right, now we need to get y by itself, so let's move the 3, minus 3, minus 3. We're left with y is equal to negative 4x plus 5. And there we have it. We create a line that's perpendicular to our given equation that contains the point 2, negative 3. It's a lot of work, right? I think you should be very proud to do these last two problems because they totally sum up everything you've learned in this entire chapter. So if you're good here, good job. If you find this challenging, that means we need to work a bit more. So maybe take a bit more time reviewing those homework problems, maybe reviewing a lecture. But this is kind of everything, putting all these ideas together. All right, Last bit, applications of linear functions. When the essential parts of a problem are described in mathematical language, we say that we have a mathematical model. So let's take a look at this problem. Amelia's Beads offers a class in designing necklaces. For a necklace make of 6 millimeter, millimeter, millimeter beads, 4.23 beads per inch are needed. The cost per necklace of a 6 millimeter gemstone beads that sell for 40 cents each is $7 for the clasp, and the crimps are approximately $1.7, so $1.70 per inch. Formulate a linear model that models the cost of the necklace, C of n, where n is the length of the necklace in inches. Okay, let's do A. So this gives us a lot of numbers. And whenever we see something with a lot of numbers, it can be kind of misleading. So if you'd like to take a moment to pause the video, read this question over a couple more times until it makes, I don't know, it's not so weird sounding, and then read your question. We want to create a model for the total cost of the necklace, where n is the length of the necklace. Okay, do we have anything that's talking to us about the cost of the necklace with a length? And we do, right? That last line. It costs $7 per clasp and $1.7 per inch. Okay, so that's where we're going to get our equation from. And yes, all those other numbers are just, they kind of seem like they're meant to confuse you, but they really are just building our story. So our equation is, instead of y, well, we can use y. Y is equal to, well, they always have this base number. No matter what the length of your necklace, you still have that clasp, that lock that keeps your necklace together, and that's always going to cost $7. So that's not going to change. Now, the length of your necklace may also affect the cost of it, and that may vary. So it depends if it's 1 inch long, 2 inches long, 3 inches long. Depends how long you want your necklace. So since that varies, we have 1.7, 0, and the length, we don't know what the length is. It depends on what each person wants. So that would be an X. But everything costs that base of $7. So there we have it. That is our equation. Now, our equation specifically asks that we use that function notation, C of n. So let's go ahead and use that. C of n is equal to 1.7. We can drop that last 0, x plus 7. That is A. Next, B, graph the model. Okay, well, we know how to graph, and we can use our y-intercept and our slope. We have our y-intercept, and we have our slope. Let's do a very rough sketch. Okay, so no matter what, I'm spending the $7. So let's go by fives. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, actually, let's go by more. Let's go by ones. So I have 5, let's do 10. 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. All right, so my y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. And then I go up. So our slope is 1.7. You can think of it as 1.7 over 1. So I go up 1 and almost 2, 1.7, and then I go to the right 1. And there we have it. We have our equation, our graph of our equation. where I guess this would be the length and our y-axis would be the cost of our necklace. And we see that if it gets longer, it's going to cost us more. Lastly, C, the question asks, use the model to determine the cost of a 30-inch necklace. Okay, well that just means we have to substitute our x for 30. So cost of a 30-inch necklace. Okay, so we want C of 30 so that we can get comfortable using that function notation. And all that means is we're going to plug in the 30. So I have 1.7 times 30 plus 7. Okay, so let's go ahead and use our calculators, or if you have a phone handy, let's work this out. So 1.7 times 30, that gives us 51, plus 7, we get 58. So the cost of a 30-inch necklace is $58. All right, not so bad, right? So this concludes our section 2.6, finding equations of lines and applications. Thank you.